Hello, so in today's class, we will look at the polar equation of a circle. Now, I have taken this figure here. So here you have the fixed point, which is our pole, and the fixed line, which is the initial line in the complex plane. And you have a circle, which is centered at the point C, and the coordinates of C are C and alpha. C will be this distance from the C will be the distance from O to this point, and alpha will be the angle of inclination. ഇനി സർക്കിളിന്റെ റേഡിയസ് A ആണ്, and P of r theta is any point on the circle. So r and theta varies along this circle. So from the origin to this point P, this radial distance is denoted by r, and the angle of inclination is denoted by theta. Now we need to find the locus of all points r theta such that it is at a distance a from the point C. So that will basically give us the equation of the circle. Now when you form the equation of circle, that will be an equation involving r theta, then C alpha, A and theta. So let us see what is the equation of the circle. So let C alpha be the polar coordinate of the center C of the circle of radius A with respect to pole O and initial line points. And let us take P of r theta to be any point on the circle. Now from triangle OCP, so from triangle OCP, so we have this distance, so this length of OP will be, so we have OP equal to R, OC equal to C, and CP will be equal to A, and angle POC will be equal to theta minus alpha. So from triangle OCP, so we will get, so by property of triangles, so CP square will be equal to OC square plus OP square minus 2 OC into OP cos theta minus alpha varum. So that will give, now CP square will be equal to A square. So A square will be equal to OC square is C square, OP square is R square, minus 2 CR cos theta minus alpha varum. Now let us write the equation in the form. So this can be written in the form R square minus 2 CR cos theta minus alpha plus C square. I am taking A square also to the side, so equal to 0. So this is the required equation of the circle. So this is the polar equation of the circle. So we will get an equation involving r and theta and C alpha and A. So this represents the polar equation of circle. Now let us look at a few special cases. So the first special case is if the initial line passes through the center of the circle, so let us look at what happens to the equation of the circle. Now, if the initial line passes through the center of the circle, അതായത് ഈ OC എന്ന് പറയുന്നത് initial line passes through the center of the circle. That means C must lie on the initial line. If C lies on the initial line, our angle alpha will be equal to 0 in that case. So in this case, the initial line passes through the center of the circle, then alpha is equal to 0, then equation of circle becomes, so in that case equation of circle is, so alpha equal to 0, substitute here, so we will get r square minus 2cr cos theta plus c square minus a square equal to 0. So that becomes the equation of the circle. And the second case is if the pole is on the circle, so if the pole is on the circle, so let us look at what happens. So pole means this, അതായത് നമ്മുടെ പോയിന്റ് O എന്ന് പറയുന്നത് സർക്കിളിലാണ്. സോ നമ്മുടെ സർക്കിള് ഇങ്ങനെ ഒരു പോയിന്റ് ആയിരിക്കും നമ്മുടെ പോൾ വരിക. Now, so O lies, when O lies on the circle, what happens is the distance between O and C will be equal to A. അതായത് നമ്മുടെ C എന്ന് പറയുന്ന value. So here OC is the distance between C and A. Now if O lies on the circle, any point, the distance between any point on the circle and the center must be equal to A. So in this case, C will be equal to A. So let us see what happens to the equation of the circle. So if the pole is on the circle, then we'll have C equal to A. Then equation of circle is, so when C is equal to A, you will get r square minus 2ar cos theta minus alpha varum plus c square minus c square അല്ലെങ്കിൽ a square minus a square equal to 0. So that implies you will have r square minus 2ar cos theta minus alpha equal to 0. Again an r will cancel off here, so we will get r equal to 2a cos theta minus alpha. So this will be the equation of the circle. And again ഇതിനെ നമുക്ക് expand ചെയ്ത് കഴിഞ്ഞാൽ, so we will get cos theta cos alpha plus sin theta sin alpha. Now here alpha is a constant value. അപ്പോൾ നമ്മുടെ center എന്ന് പറയുന്നത് fixed ആയിരിക്കും. So this angle is going to be fixed. So 2a cos alpha can be replaced by a constant a. So we will get in the form r equal to a cos theta. And in the second term, 2a sin alpha can be replaced by another constant b. So the equation of circle will be in the form r equal to a cos theta b sin theta. So if the pole is on the circle, then the equation will be of the form r equal to a cos theta plus b sin theta. Now let us look at the third case. Now the third case is if the pole is on the circle and the initial line passes through the center. So this is the last two cases combined. Pole is on the circle എന്ന് പറയുമ്പോൾ, so that is, we will have C equal to A. When pole is on the circle, C is equal to A, and when the initial line passes through the center, we will have alpha equal to 0. So therefore, equation of circle is in this case, so we will get, ഇപ്പോൾ നമുക്ക് ഈ കിട്ടിയ ഇക്വേഷനിൽ ആൽഫ ഈക്വൽ ടു 0 മാത്രം കൊടുത്താൽ മതി. അപ്പോൾ we will get r equal to 2a cos theta. So the equation is r equal to 2a cos theta. So that is the equation of the circle when pole is on circle and the initial line passes through the center. Now the next case is if the pole coincides with the center case, we will have circle in this form. So any point r theta will be at a radial distance a from the center O. So in that case, theta can take any value, so r will be always fixed. So we will get r equal to a. So this is the most simpler equation of the circle. നമ്മൾ circle center അടുത്ത origin എടുക്കുന്ന പോലെ. So this will be same as x square plus y square equal to a square. So if the pole coincides with the center, so we will get the equation of circle to be r equal to a. This case is if the initial line touches the circle. So our circle is such that it is going to touch the initial line. So you can see that circle is touching this initial line exactly at this point. So let us look at what happens in that case. Now this is the center of the circle and the initial line touches your circle. So that becomes a tangent to the circle. Now when you take the angle between the radius vector, അപ്പോൾ ഒരു പോയിന്റിലെ ടാൻജന്റും അതിൻ്റെ ആ പോയിന്റിലുള്ള റേഡിയസും they will intersect at right angle. So therefore from this triangle, so when you take this, let me take it as OA. So this point is C. From the triangle OAC, so since it's a right angle triangle, so we will get sin alpha equal to A by C. So A is the opposite side and the hypotenuse is C. So we will get sin alpha equal to A by C, or that gives C equal to A cosec alpha. So if the initial line touches the circle, in that case we will have C equal to A cosec alpha. So therefore substituting this value of C into the first equation. So then the equation of circle becomes, so we will get r square minus 2. So C becomes A. So there will be AR cosec alpha, then cos theta minus alpha, plus C square will become A square cosec square alpha minus A square equal to 0. So upon simplifying, you will get r square minus 2AR cosec alpha cos theta minus alpha plus A square cos square alpha equal to 0. So this is the required equation of the circle when the initial line touches the circle.